So we are a non-profit based in Berlin, in Germany, although we work internationally. We do science communication and especially mathematics communication. Our main activity is preparing exhibitions. We started in 2008 with the first exhibition. It was prepared by the Mathematics Research Institute in Oberpolfach in the Black Forest in Germany. And since this exhibition, at the moment, Imaginary didn't exist as a company or as an association. It was just the name of the exhibition, and then it grew. Here I have some of the pictures of activities we have been doing. Now we have been doing things in Africa. These are some of the exhibitions. I think this is one of the first exhibitions. I think this is in the train station in Berlin. This is in Korea. This is in Deutsche Museum in Munich, if I'm not wrong. So this is in London. So we have some of these exhibitions. We prepare all these materials, mostly digital things. This is an exhibition. This is an exhibit. This is permanently on the Museum of Mathematics in New York that we prepared. So we do mostly digital things, and now we are also exploring some of physical things like with 3D sculptures and some stations that we can show in different places. So these are some of the pictures. If we go down, we have some of our latest projects. We have lately done an exhibition on artificial intelligence that unfortunately we had to put it on hold because of the pandemic. So now it is an online exhibition, although it was in the middle of the preparation when the lockdown happened. Another exhibition we had before that was shown for a year, just in 2019. It was about mathematics and music. It was a quite successful exhibition. And we are now preparing a very short museum, like we call it as a 10-minute museum, and we are working on, so this small museum will be about the climate change, about the climate crisis that we have. And other than exhibitions, I can show you here some projects. We lately made an installation in a shopping center in Heidelberg in Germany, putting some math exhibits in a shopping center. We also collaborate in the organization of the International Day of Mathematics, in collaboration with the International Mathematical Union and the UNESCO, who was that to declare this International Day. And now, since this last year that we have been on the lockdown, we have been doing a lot of virtual workshops about materials that we have from our exhibitions from artificial intelligence and music mostly. Here, if you are interested, you can see a bit of our journey, our timeline of what we have been doing lately. And this is a world map where we have been putting some of our exhibitions, or where our materials have been shown. It looks like it's all over the world. The trick is that nobody has been in all these exhibitions. It's just because how we work. So we rely on open licenses and we share everything. So everything we do is under Creative Commons and free software licenses. So everybody can replicate and adapt it. So that's the key for that's the secret for having exhibitions all over the world. Okay, so this is a little bit of our background, imaginary.org, if you want to know more. And right, and one of the projects we have been doing is Mathina. So Mathina has this 4 lands here to discover different things, and the one that we have been working is the birds of fire. So I will tell you a little bit of why we decided to have this this setup and what do we have there. So yes, the firebird trainer is the first story. So Mathina and Leo were going on a stroll in the fields, and they found this this mysterious lady that was looking to the skies, and they asked her, "Who are you? Are you a warrior? Are you a wizard?" And she said, "Well, I am a firebird trainer, because there exist these these firebirds, and the first firebird that we can find is this unidragon. So, what is that? Oh, that's yeah, this is the unidragon. So it's a mixture of a unicorn and a dragon. And the story goes like this, that these unidragons are like dragons, but they are born with a horn on their heads. Like the milk teeth in the children's, this horn falls at some point in their life when they are getting adult. But this horn that it falls is not a dead material. The dragon still can feel it. And this is the magic one that this lady, Flamma is her name, that she has on their hands. So this is not a magic wand, it's the horn of a unidragon. And the unidragons can still feel it. So since the unidragon can still feel it, you can use it to communicate with the unidragon and to give some instructions. And essentially the key idea is that this horn is a vector. So here we have the idea of direction. Here we have the idea of action to distance, so that the position and the direction are two different magnitudes, two different things. And the story goes explaining a little bit all of this. And then when we go here to fly the unidragon, then we can go to this app that says, well, here you have the dragon that is flying, and here is the magic wand, which is the same as this horn, because it was the horn that the dragon used to have before he was adult. So you can move it, and you can make these curves in the sky, because since it's a firebird, it is burning inside, so it releases some smoke and it stays on the sky. So here we can see this curve that is drawing the unidragon in the sky, and you can see that the horn on the head of the unidragon is parallel to the horn in the hand of Flamma. So this is our story for the youngest children, so 4 to 6. The story can be read by the parents or can be read in the school by the teacher, and the children can play a little bit with this, can play on a touch screen or something, and it is mainly an exercise of coordination between hand and eye. What we are seeing on the screen, what you have to coordinate. It's a psychomotricity exercise on one hand, and then they get this idea of the direction, and you can also change the magnitude of the vector, so you can fly faster or you can fly slower. And yeah, so the important thing is that here there is one thing which is the position where it is, and the other is the speed. And the speed is something that you can have the speed as a scalar vector, so as a number, but you can have also the velocity vector that it has some direction. So this is all these ideas. We are not telling them, we are not using the word as speed or vector or magnitude or direction. So this is all just ideas that are getting inside the brain of the children and getting behind, because they are just they don't need it. They don't need it for playing this game, and it is just something that gets in the background. So this is just the first app that it's free play. Then the story continues, and they say, well, these fire dragons, they eat this instead of meatballs, they eat fireballs, and then you can have the same game. Now it's a bit more fun because you have some goal that you have to be collecting these balls around. So it is just the same. It's the same game, but now you have to collect it, and if you crash against a cloud, then you got restarted because the fires the unit dragons don't like the clouds, and they get back. So now it's a bit more more fun, the game. And then on the last game, you have to follow these lines. So this is the Flamma is this lady is a firebird trainer. So she trains the unit dragons to make some of this to tell them how to fly or how to follow. And there are competitions in this land, and some wizards compete, and then you have to follow. And here, of course, for children, this is just the basic shape recognition. So you can recognize this is a triangle, this is a square, this is a circle, and you can follow it somehow. But it's very interesting that even if you are not 4 years old and you read this as an adolescent or as an adult, well, you can still get some hints, and it is something that is described on this educator repository that says, for instance, well, here you are describing the curves constructively. So this is like, well, if you want to draw a triangle, you have to put the pencil on the paper, and then you have to constructively make this line, and then turn this 60 degrees interior angle or the complementary or this 120 degrees to the normal. So you have to go far, go straight, then turn, go straight, and this is something that you can give these instructions here, and it is fundamentally different from the definition by properties. So you can define a triangle that it's a shape where all the sides are the same size and are equal. So that's an equilateral triangle. And the square has 4 sides, and they have the same length, and they also have the 4 angles are equal. And this is a definition by property. And here we have a definition by construction. And this is something that you can experiment, and you can reflect on it, not when you are 4 years old, but if you find this game when you are older, the teacher or the educators can tell you, okay, so what are the ways for defining a shape? And essentially here, we have a parametric description of a curve. So you have a parameter, which is the time, and then you for each time you have a point, and it's moving on the screen. So this is a parametric description of the curves, and this is something that you can reflect much later. So this app and this story is not obsolete when you are older. You can always come back and learn a little bit more on this. So the second story we have here is talking to the unit dragon. So the story goes like this: that Mathina and Leo, they come back to the same field where Flamma was, and they see that Flamma is also conducting or driving a unit dragon in the sky. But now she doesn't have the stick on the hand, so she doesn't have the horn. So what happened? And then the Flamma just explains that this poor boy, this poor dragon, lost the original horn, because it was flying over a lake, and the horn fell into a lake, and it sunk. So now nobody can drive her, so it cannot be trained. But then Flamma said, well, I will train it anyway. So since I don't have this graphical input, since I don't have this stick, I will use some language. Oh, so what is this language? I will use magical numbers. Oh, magical numbers. How can you talk with numbers? And they say, well, the direction can be described by numbers. And then Flamma shows a little bit of how to use these coordinates without saying coordinates in a moment. And essentially, Flamma explains how you describe vectors with pairs of coordinates, pairs of numbers. And then you can get to this app where you can play with that. And this is the first app that you can have, and then you can say, okay, so I can take number 1, and then the dragon flies. I can say another one, and it flies. And if I put it in the second coordinate, it will go upwards. And if I put in both, so this means go 1 step forward, one step upwards, and then you can play, and then you can learn. So what does it take for our children to understand this? So it has to understand this relationship of numbers and lengths, which is something which is really early in the school. And yeah, probably you can even predate, you can do it even before they know about the negative numbers, or at the same time that they know about negative numbers, because, well, negative numbers is just going the other direction. So this is 2 forwards, and instead of raising 2, well, it's going downwards. So this is just a symbol that you can put. So you can do this at the same time that they discover the negative numbers. But usually you don't teach vectors at the same time as you teach negative numbers, because vectors is something much more complex. And when you teach vectors, you want to talk about the length of the vector, and then you want to talk about the Pythagoras theorem, and then you need and you probably want to talk about the dot product and the product of the vectors. And so there is plenty of things that you usually want to talk when you talk about vectors. So you delay introducing this idea of vectors to the moment when you have all this background. But here, what we are saying is that, well, for having this just basic connection of pairs of numbers, it's an arrow. This is something that you can do really, really early, and we think it's good to have it really early on the on this non-formal training. It's just a very shallow introduction of vectors. So the story continues. It has some challenges here in the same way. So the first was just a free flight. Here you have a goal to reach the castle without clashing against these mountains or the clouds. Here there's another interesting twist, is that you can add the number, and then it just keeps it in the memory. So you can have one vector, and then you can have another vector, and then you say add. Yeah, it's very naughty to say add, because it adds to the list. But of course, the goal here is that the children themselves discover that this has some additive structure. So that, for instance, if I put these 2 vectors here, and this is just in the memory, so you tell it to the Unidragon in advance, when you say go, it goes these 2 vectors. And where does it finish? Where is this position that you have at the end? Well, it's, of course, is the addition of the 2 vectors. So this vector plus this vector. So it's the addition. So it is not only adding to the list, it's really what you get at the end is the addition. And this is something that is hinted in the story, and it is something that you can kind of help the children discover by himself or herself. This is put on this educators repository. There are some hints of what you should try to make them discover this by themselves, not tell them directly.
Danielle,
okay, yes.
Danielle, I hate to interrupt,
sorry.
but we do need to get to the last 2 presentations, and we're very near our time limit.
Okay, so this is a bit of the presentation here. Story number 3 is still pending, and number 4 is about implicit surface, that I will just show you the picture, and I will let you to discover by yourself. It is this very
Thank you.
Nice. Let me show you. Yeah, so in number 5, this is for the older children.
Yes.
It is where these firebirds are these microscopic birds that they put themselves into implicit curves, and I think it's very nice that you can discover later. Okay. Sorry for exhausting my time. Yeah.